Let's be honest, we are absolutely swimming in data. It's everywhere, in our health records, our finances, on social media. But all this raw information, these endless streams of numbers, can just feel like noise. So how in the world do we find the actual signal in all that noise? Well, that's exactly what we're going to tackle today.
And this quote from John Naisbitt, it just nails it. We are drowning in information, but what we're really after is knowledge. The goal is to bridge that gap, and we're going to do it with a really fundamental toolkit from the world of statistics.
So where do we even begin? I think we have to start by just facing the problem head on. Raw data, especially in a field like medicine, isn't neat and tidy. It's usually this chaotic jumble of numbers and text that, on its own, is, well, it's pretty much useless.
I mean, just take a look at this. This is what you're often up against in the real world. It's a mess. See those circled areas? We've got missing values, we have inconsistencies, weird formatting. How are you supposed to calculate an average when some of the numbers have a less than symbol and others are percentages? You can't. It's impossible. This is the chaos that we need to tame.
This is where statistics comes to the rescue. It's really the science of learning from data, giving us the tools to clean up this mess and find the story that's hidden inside. We're going to start at the very beginning with the most fundamental branch, descriptive statistics. Now, it is so important to get this distinction. Descriptive statistics, as you can see, is all about the data you have. It's about summarizing what is right in front of you. Inferential statistics, on the other hand, is about the data you don't have. It's where you take a small sample and try to make an educated guess about a much larger group. Think of it like this. It's the difference between describing the 10 people in a room versus using those 10 people to predict what an entire city thinks. So just to be crystal clear, with descriptive statistics, our only goal is to organize and summarize the numbers right in front of us. We are not trying to predict the future, we're just trying to make the patterns in our data easy to see, turning that messy spreadsheet into a clear, understandable picture. All right, so how do we start describing our data? Well, the very first step is to find its center, or what you might call a typical value. This gives us a single number that can kind of represent the whole group. The most common way to do this is with the mean, which you probably know it as the average. You just add up all the values in your data set and divide by how many of them there are. Simple and really, really powerful. But, the mean isn't the only game in town. We also have something called the median. To find the median, you line up all your data points from smallest to largest, and you just find the one that's smack dab in the middle. Half the data is smaller, half the data is larger.
So why have two? Well, the mean is fantastic when your data is spread out pretty evenly. But what happens if you have an outlier, a really extreme value? Imagine you're calculating the average income in a room of people, and then a billionaire walks in. Whoa! Their massive income would drag the mean way, way up, making the whole group seem much richer than they are. But the median, the person in the middle, would barely budge. So the key takeaway here is this. The mean is sensitive to those extreme values, while the median is robust.
Okay, so knowing the center is a great start, but it's really only half the story. We also need to know how spread out, or how dispersed, our data is. Are all the numbers clustered tightly around that average, or are they kind of all over the place? For example, let's say two classes both have an average test score of 85%. Sounds the same, right? But in one class, everybody scored between an 80 and a 90. In the other class, the scores went from a 60 all the way up to 100. See? Same average, but a totally different story about how consistent the students are. Measuring the spread tells us that other half of the story. Now, the simplest way to measure spread is the range. You just find the highest value and subtract the lowest value. Boom! It gives you a quick, super easy to understand sense of how wide your data is spread. But for a much more powerful measure, we turn to something called the standard deviation. Now, I know it sounds a little technical, but the idea is actually pretty simple. It calculates a single number that represents the typical distance of any data point from the average. Think of it like the average amount of spreadiness in your data. A small standard deviation means everything's clustered together. A large one means your values are all over the map. And this is where standard deviation becomes a bit of a superpower, especially for data that follows this classic bell curve shape. It gives us this incredible rule of thumb. For this kind of data, about 68% of all your values are going to fall within one standard deviation of that center line, the mean. About 95% will fall within 2, and pretty much everything, 99.7%, falls within 3. This predictable pattern is an absolute cornerstone of statistics. Okay, so we've got ways to measure the center, and we've got ways to measure the spread.
Now let's see the real magic happen when we combine these concepts to tell a visual story with our data.
This right here is the real payoff. We don't just calculate these numbers to stick them in a table. We use them to create powerful visualizations. Charts like histograms and box plots, they are built directly from these ideas of center and spread, and they let us understand a whole data set in a single glance.
And this slide illustrates that power perfectly. On the left, you got a histogram showing the frequency of different cholesterol values. You can see the overall shape of the data. But now look at the box plot on the right. It's summarizing this same data, just differently. That line in the middle of the box, that's our median. The box itself shows you where the middle 50% of the data lives. And most importantly, do you see those two little dots way out to the right? The box plot instantly flags those as outliers, telling us exactly which data points need a closer look. It literally turns a boring list of numbers into an actionable insight.
So let's do a super quick recap. Descriptive statistics are our essential first step for turning that data chaos into clarity. We use measures of central tendency, like the mean and median, to find a typical value. Then we use measures of spread, like the range and standard deviation, to understand how varied the data is. And when you put them all together, you build a solid foundation for really understanding data.
And that really brings us to our final thought for today. We've seen how these pretty simple tools can reveal so much: the shape of the data, its center, its spread, and even those weird values that need investigating. So it leaves us with a really critical question. If a simple summary can be this powerful, what critical mistakes are people making every single day when they just jump straight to complex conclusions without ever taking this essential first step?